Hello everyone, my name is Gael Ramos, and today I'm going to present my project, Mimic Gaunlet. So, researching about different things, I just taking into consideration accidents and disabilities. I just found that almost 2 million people suffer from disabilities or just different problems in the hands. And this is a very big problem because not only this population, this part of the population would suffer from joint pain, muscle weakness, diseases, reduced strength, and many other more problems. But since the hands are the very first thing that keep us from interacting with the real world, they will suffer for a very rough life and daily life. So usually in these sort of cases, they require therapy or reconditioning to just gain some of the functionality that was lost. But in many other cases, they can result in long-lasting recoveries or just permanent damage. And this is not good for many of the populations. So in order to I be able to make them have a better life and just more suitable for living, I had some goals to create a project about this. But it was create first a device that will assist with different individuals who suffer from disabilities or problems in the motor skills related to hand motion. And then second is to promote the research on different prosthetic connections from the brain to the body. So I can help the general industry with information and prototypes in which it could be based to just improve the overall cost, effectiveness, and just improve the industry in any way I can. So in order to make this possible, first I need to understand how the hands actually work. So first we're gonna take a look into the bones. The bones are the structure of the hand, and they are very important. So we have first the phalanges that are our fingers that they have for support and also for motion, separating into three different types of phalanges. Then we have the metacarpals, they're like the palm of your hand, they're the base of for the phalanges and the carpals. The carpals are most like over for our wrist, for support for our wrist. And then we have the forearm bones, that is the radius and the ulna. The radius is located all over the thumb, and the ulna is located on the opposite side. Since the bones are the support of the body, we will use them for support not only for the device, but also we need it for support for our hand. So these are very crucial parts of the hands. Then we have the muscle. There are many muscles in the forearm and the hands, but we need to focus on different ones that is the extensor and flexor. As the name says, these serve to extend and flex the fingers, and they are located along the palm, being the flexors, and along the dorsal of the hand and forearm, that is the extensors. Connected to these ones, we have also the tendons. That these tendons are from muscle to bone, and these having the same name as the muscle groups, extensor and flexor tendons. These both serve for flexing and extending, so basically we need to contract and just fully get excited our fingers. They are very important because for these fine movements, we need to be able to replicate them very specifically so people will have a no delay in their hands and be able to just close them, open them, and use them as regularly as they want to do it. And then finally, we have a very important piece that is the nerves. The nerves is the main communication system of the body, and this will go from the brain all the way from the spine to different parts of the body. In here, we will focus on the median, ulnar, and radial. Median and ulnar are located on the palm, and they go from the middle to the two different sides. So, being the ulnar going from the middle to the pinky finger, and the median going from the middle all the way to the thumb. And finally, we have on the dorsal of the head, have the radial nerve that goes all the way from the thumb to the middle finger and almost the pinky finger. Since this is the communications of the brain to the body, it is very important to acknowledge this so we are able to use it for our purposes. For the project, I'm gonna use different strings, 9-volt batteries, servo motors, 3-pin filament, and specifically PLA, EEG muscle sensors, gloves, microcontrollers, rubber cables, and cables. So to start this, first we need to acknowledge what it is an EMG sensor, or most specifically an electromyogram sensor. It is a sensor that detects the electrical activity on the muscle. Since every group muscle is composed of different fibers, these fibers are not always on or off. So they will basically be in a random paces, in which some of them will be fired on at different levels, and others will be completely off. And this is not suitable for different programming functions and for uses because there are different voids that we could be mistaken about no use of the hands. So in order to be able to use them, these sensors basically take the raw data or the raw EMG and take an average of it. And with this average, they create an empty envelope, as you can be seen on the bottom. So this can be more suitable for using and more controllable and seeing how actually this data is helpful for our purposes. So as an engineering project, it is very complex, but we can separate it into different parts: the process information, the controlled information, and the biomechanic implementation. First, the information processing starts from the sensors. These sensors will read the muscles of the extensor and flexor and will gather the EMG data. This data will be sent to an interpreter and then this will make an average, creating an envelope of EMG as it can be shown on the left. This left is will be read and will be processed in the control information. In this information, the controller will get a path. So basically like a road with a start and an end, with each point of this having a different set of values for the motors. So locating in what piece of this path the EMG value is, let's say for example, just in the middle, we will the controller will say, okay, since this is on the middle, we will set both values of the start and end of the motors and get the middle value. And this middle value will be sent into the motors just so in order to the fingers be able to have a middle value mimicking the actual movement. And this data was sent to the motors and into the third part, that is the biomechanical implementation. In this part, the middle value of the motors will be read or say, okay, so now analyzing the finger and transforming its movements of flexion and extension into like a strength type of movement, as you can see on the right, I will move the motor at a certain angle in order to tighten or release the string. And with this tightness or releasing, I will be able to have a more controllable motion and each finger will be able to move at a different pace that it is supposed to do, being breathed by the muscle. And so basically what we result is a prototype that reads the data of our muscles and mimics the same type of movement with the motors and using strings. So getting this information with this prototype, I get to different results to different prototypes, and I was able to gather different information and use of different types. And for this, in conclusion, I was able to create a device that was capable of mimicking the hand gestures and motions. And it was very important because has a lot of filter into recoveries and also in for investigation purposes for improving the prosthetics. However, the capabilities of assisting in a daily life usage, they are still proven to be a little bit doubtful. But still, the capabilities for being a research purposes is very, very high and have a very young purpose in the future. Because of this, in the future research, I want to continue this idea of promoting prosthetic information and investigation, most importantly using brain signals. So my project is mostly aimed into not a connection with the muscle prosthetic, but most prosthetic connections. And using a brain signal, I will not only be able to have a better reading about what the user can do. So this will not only be limited to people that has just the hand disabilities, but we want to create a complete arms since people that do not have any part of the muscle will not be able to use the EMG sensor. But using a brain signal, we'll be able to train those people into getting brain activity that they do not have. And using this, we're able to also improve on different area of engineering or for not of engineering, that is the medicine. Because understanding how the brain and the neuron works and the connections and how they're created, we can understand different diseases and be able to improve them. And for example, things like Alzheimer or just being paraplegic, we were able to create new paths of neurons to be able to read and to improve and just have a cure for these type of problems in the future using information that can gather using the brain signals and the prosthetics. And so because of this, thank you for watching and see you later.